Welcome back. Next up, we have Hong from Phala Network, who is going to discuss cross-chain message passing and how it makes confidential computing composable. Welcome, Hong.
Hello. Hi, guys. I'm very happy to be here. Thank you. All right. So today I would like to talk about the XCMP. So how XCMP can make the confidential computing composable. So I'm Hong Ying. I'm from Phala Network. I'm the co-founder and the lead developer. Yeah. So before we start, first of all, I would like to introduce you that Phala is actually a trustless confidential computing cloud infrastructure. So when we're talking about a computing cloud, so how can we build a trustless cloud? Like in the cloud we're familiar with, we have Amazon cloud, we have Azure cloud, and they are scalable for sure. You can scale to maybe thousands or even 10,000s of computers within just one click. And it's supposed to be privacy preserving. Whenever you put any data on any cloud and without the authorization, nobody can access your data. This is supposed. But when we are talking about trust, maybe the first word we can come up with is blockchain. Because blockchain offer us a trustless system, and it can offer a kind of computation happening on the blockchain. We don't need to trust anyone, any single party. But blockchain has some problem. The biggest problem, I think, is about privacy. Everything stored on the blockchain is actually transparent. So no matter what you input into the blockchain, you can find it out from the blockchain history. And it's not scalable as well. So if there is any solution to overcome these problems, combine them together to create a trustless cloud. So at Phala, we found out there is a very interesting technology called hardware secure enclave. Unlike the other approaches, hardware secure enclave is like a combination of the hardware and the software. Actually, hardware enclave is it's already very common. As long as you use maybe some Intel CPU or some AMD CPU, you may already have some secure enclave built in your CPU. It's a special area. It's like a black box. You can put some applications into the black box. And because it's well isolated, everything inside the black box is encrypted. And only the authorized operations can have the access to the data or the logic inside that. So if we run some smart contract into a secure enclave, it naturally become so-called confidential smart contract because everything is confidential preserving by default. However, even if we have the secure enclave, it's kind of trustless because like even I'm the system operators or I have the access to hack into the hardware. The secure enclave can still protect the access and the data inside the enclave. So you don't really need to be very concerned about the unauthorized access to the secure enclave. It's privacy preserving because everything is encrypted. Only the authorized operations can have the access. It's scalable because you can easily stack maybe tens of thousands of secure enclave workers, and you get tens of thousands higher throughput compared with just a single worker. But it's not like a solution to everything. It's not resilient to single point of failure. But a very interesting point is that blockchain actually have this characteristic. So how about we combine the blockchain and secure enclave together? We can use this blockchain to organize maybe thousands of secure enclave workers and have them working together to protect the data inside and also provide the service to the cloud computing developers. So everything looks very good. like Ethereum, we only have unsharded Ethereum. It's just like a single shard. No matter how many nodes are added to the network, it still doesn't increase the overall throughputs. And Polkadot is much better. Polkadot has Parachain. So like maybe we have 100 Parachains and we can have theoretically maybe 100 times more the throughputs than Ethereum. On Phala network, we can have maybe tens of thousands of workers easily stacked to create a linearly scalable system. And everything is organized by our blockchain. It sounds really good, right? But it comes with some costs. The cost is actually a very common problem in any decentralized distributed system. So because everything is running in an asynchronized environment, a real problem is how do we handle the communication within the different components reliably and securely. First of all the communication is asynchronized. And then we need to make sure the ordering of the message is canonical. Otherwise, it may introduce some problems of maybe double spending. And of course, we also don't want to miss any message in a communication channel. So actually, this is not a new problem to me. Polkadot also have a similar architecture. It has a relay chain. It has up to 100 parachains, and the parachains run in parallel, and they are synchronized, asynchronous, and heterogeneous architecture. And the solution provided by Polkadot is called XCMP, the Cross-Chain Message Passing Protocol. It used the relay chain as an anchor to validate all the messages passed between the different parachains and make sure the entire communication is secure. And of course, as a part in the Polkadot ecosystem, we also have the similar problem. And naturally, we want to use XCMP to solve the same problem. And maybe to the surprise of some people, XCMP is even more powerful than you may expect it. It's so generic. It can even handle the location of each individual smart contract or individual secure enclave workers in Phala network. So in this way, we can be fully compatible with XCMP, and we can have worker-to-worker communication and worker to the other parachain communication through XCMP. So okay, now we have XCMP, and let's see what we can do. Can we make the confidential contract composable? A really easy and simple feature offered by XCMP is transferring of the token. Like just suppose we have a Ethereum bridge on the left side, we have Polkadot on the other side. And here we can initiate a transaction from Ethereum parachain to withdraw some assets. Like we show in this slides, we can withdraw like 1 Ether from Ethereum bridge and send this message to Phala network. And on the Phala network side, the effect is deposit some reserved assets. And as you can see, the interesting part is that it doesn't send the token to just an account, but it sends to an account located on Phala network. And in this, and it looks simple, but in this process, it is Polkadot XCMP to make sure this transaction, this message is fully validated, is secure in this communication process. And this is offered by a characteristic called shared security. And with this, because we already have the secure enclave workers, and how about we put the ERC20 token, ERC20-like token just in the smart contract? We can get what we are working on is called Face Wallet. It's a wallet designed for privacy. You can use this wallet to store some assets. It's encrypted and all the transactions on the inside this wallet is invisible on the blockchain. And because we can connect to Polkadot through the standard assets XCM message, so it can accept all the assets from the other parachains without a single line of code change. And of course, we have this wallet. We can also put a decentralized exchange to the confidential smart contract and combine them together. You can not only store the assets, you can also trade the assets. They are composed by XCM. We can also have like a loot box, and we can put maybe some Zcash coin into the loot box through XCM, and we can create like a lottery for the Zcash inside the loot box. We can transfer that into the other parachains to make it very fun. You can use it in any game blockchain. And we use XCM here to compose the different types of applications together to create some use cases that was never possible in the past. Okay, so far so good. So we have the composable confidential smart contract dealing with the assets, but as like we are building the cloud infrastructure in the Web3 area, how about we take one step further? So I think we can talk about the web. And in Web3, we believe that all the data should belong to the users, not to these big tech companies. But in the reality, nearly like 80% of the internet traffic is tracked by Google Analytics. It's handled by just a single company. So this is a problem. How can we fix that? So in because we already have the confidential smart contract, maybe we can handle all the data inside the confidential smart contract instead of any central party manage the database. So what we want to make is like a kind of personal data vault, and the data is collected from the user. It only lives inside the data vault. It lives in the trustless decentralized database. The raw data never comes out the database without any authorization. So in this way, user can have 100% control over his own data. We can have an application called Web3 Analytics. On the one hand, we can offer personal data console. It can be used to manage all the data setting, privacy setting, just like you have a mobile phone and there are the privacy setting in your mobile phone. And in the Web3 Analytics, all the data collected by the service are handled by the personal data console. You can authorize, and only if you authorize the data, the developer can analyze it. And again, in this process, all the raw data is still kept inside the data vault, and without your authorization, nothing can come out of the confidential smart contract. So in this way, you still control 100. You still have 100% control over your own data. And as we can see, if more and more data are collected into the Web3 Analytics, and naturally this data can create the value. The data can be organized as the data sets. And on the other hand, there are business and data analysts. They have the demands to analyze the data. So it can be formed as a series of data analytic requests. So these are the demands. And on the left side, these are the supply. And there are demand and there are supply. It creates a free market on the data. So we call that a free data market. But of course, due to the complexity of the privacy data, it's not like automatically collected as the data side. We must introduce some role called the data brokers. It acts as liquidity providers. They can help the users to organize the data. And on the other hand, there should be auditors to make sure all the data analytics requests comply to the privacy setting by the users. So in this way, we can create a data market. The data is not just the data, it can create a revenue stream for the users, and user still have 100% control over his own data. And if we have such a data market, we have Web3 analytics. In this whole process, it's not just like a single application can be handled by Phala network or any single application. We still need the storage from maybe some decentralized storage service. We still need the decentralized ID. It can create the credibility for the business, the code audits, and all the entities in this service. We also need the DeFi infrastructure because we can have the liquidity created from the data market. We can use the DeFi to bootstrap and make the liquidity better and provide more revenue to the data holders. And everything is composed by XCMP, and that is only available on Polkadot. Yeah. All right. So in this talk, let's just summarize. In this talk, we have introduced the Phala network, which is a scalable privacy-preserving cloud. And in order to achieve that, we organize tens of thousands of secure enclave workers together. But it creates a problem. Just like any asynchronized distributed system, we need a way to establish the secure communication channel. And that is how XCMP can help. With XCMP, we make the confidential smart contract running in the secure enclave workers composable. And we can even make one step further. We can not only deal with the assets, but like the data, provide a real solution to help the user get back the control of their own data from these big tech companies. So I think that is how we can make the Web3 world a better place. Yeah, and that is our vision. Thanks. This is my talk about Phala and how we can use XCMP to make everything composable.
Awesome. Thank you so much. What a great talk. I got a couple questions here from the audience. The first one was, and I think this is a sort of a question that is underlying a lot of conversations and around security that we have in the crypto and Web3 space is like, are we sort of just like offloading some of that trust to the hardware manufacturers? And what are your thoughts around like, which hardware people should trust over others, and if people should be really concerned about those concerns?
Yeah, I think that is a really good point. So by introducing the secure enclave, as you said, it's actually offloading some security assumption to the hardware itself. We don't see this as the only solution to all the privacy preserving the demands. Like we have zero knowledge proof, and we also have maybe secure multi-party computation. They have their own use case. They have maybe less security assumption compared with secure enclave, but the secure enclave can provide a very effective, efficient way to provide a service comparable to the existing cloud infrastructure like Amazon and Azure. So I think it's just a problem of the different the different assumption over the security. But of course, we also have some additional secure enhancements on the single secure enclave workers. So if you're interested, you can go through our wiki page or read our white paper. We have like a few very complicated mechanism to make it a reality.
Awesome. Thank you very much. I think there's one or two questions in here about sort of how Phala and what you're doing compares to other projects folks are familiar with. So one was iExec. I assume that the difference being there's a combination of both the asset side of it and the data market. Correct me if I'm wrong. And the other one that was mentioned was Ocean Protocols, data markets, and how this compares to what they're working on.
Yeah, I think there is a very fundamental difference. Actually, the concept of data market is not new. I think when we get the idea of Web3, this is a very natural idea from the beginning. But I think the difference between us and the other project is that we actually have a very actionable roadmap. We have already built a very simple data analytics smart contract into our running testnet. And if you are interested, you can check out our code. But in the next step, maybe we can scale it from a single worker to maybe thousands of workers to make it scalable. Because it's very easy to handle maybe gigabytes or terabytes of data every day from this Web2 applications. So I think actionable is the biggest difference. Another smaller but more technical difference is that we have a blockchain, and we designed this. It's called confidential smart contract. It still have all the requirements from the smart contract. It has the very high consistency and availability, which is probably very rare to be fulfilled by the other solutions, in my understanding.
Thank you so much. Everyone stick around. We're going to have a short break, and we'll be back on the other side with Bree from Darwinia. Thank you.
Thank you.